Hello everybody, glad to see you back again. Happy to be moving along with our study of probability. Today we're going to be talking about the probability of compound events. Some good news for you, we don't really have any vocabulary words to define in our book today. We just got to review a few of the words that we've already learned. The first one that we have to review is compound event. And that's easy, it consists of two or more events. The events may be independent or dependent. Remember that an independent event is one where the outcome of one event does not affect the outcome of the second event. An example would be spinning a spinner and then flipping a coin. The flip of the coin would have nothing to do with the spin of the spinner. Okay? The other kind is a dependent event, where the outcome of one event may affect the outcome of the second event. An example is if you pull a paper clip from a cup, then you throw that paper clip away, then you pull another paper clip from the cup. That would be dependent events because there would be one fewer outcome possible in the second drawing. Okay, anyway, we learned about those yesterday, independent and dependent events. You did an IXL session to prove that you could distinguish between those two types of events. All right, so today we're going to find the probability of compound events. So let's think of a compound event. A compound event might be to flip a coin twice. That one got away from me, all right? You flip a coin twice, and it might come up heads or tails the first time. So when you flip a coin, it could come up like it just did. It could come up tails, okay? Now when I flip it again, it can come up either heads or tails. As you can see, when I flipped it, it came up heads, all right? So in this experiment, the first time we flipped it, the first toss, it came up tails. The second time we flipped it, it came up heads. So our outcome was tails and then heads. Tails on the first flip, heads on the second flip. Another possibility would have been that it had come up tails the first time and tails the second time. That would be tails and tails, okay? Now remember, on the first flip, it didn't have to come up tails. There was a possibility that it could have come up heads. If it had come up heads and we had done this, the second outcome still could have been heads or tails. So this outcome represents heads on the first flip, heads on the second flip, heads and heads. This outcome represents heads the first flip, tails the second time, heads and tails. So you can see there are actually 1, 2, 3, 4 possible outcomes. All right, you can figure that out using a tree diagram, and that can, of course, be a pain. And of course, there is a shortcut for figuring this out. To figure out the probability of a compound event, you just take the probability of the first outcome and multiply it by the probability of the second outcome, okay? So let's say I wanted to say, what is the probability of getting tails and then tails? What's the probability of that? Well, we can see from our tree diagram, it's 1 out of 4 possible outcomes. So the probability of getting tails and then tails is 1/4. Is there an easier way to do it without having to do the tree diagram? Yes, there is. In the first flip, what is the probability of getting the favorable outcome? There's 2 possible outcomes. One of them are favorable. Possibility of getting tails the first flip is 1/2. The second time we flip it, we flip a coin again. And of course, whenever you flip a coin, there's a 1 out of 2 probability it's going to come up tails. So the second time we do it, it's 1/2. All you got to do is multiply these two together. 1 times 1 is 1, 2 times 2 is 4. We get the same answer that we got from our tree diagram. The probability of tails and then tails is 1/4. Let's move on. What if we had a spinner? You guys have all seen spinners before. You flick it and it spins around and it lands on something. Let's say the numbers on this are 2, 3, 4, and 5. Okay? And I want to say, what is the probability of getting 2 and then even? The first thing you have to ask yourself is this an independent or dependent event? And clearly a spinner, they're independent. No matter what I get the first time, the second time I can still get 2, 3, 4, or 5. Okay? So probability of 2 and then even. We could draw a tree diagram, but we're going to use the shortcut this time. We're just going to say that the probability of getting a 2 the first time is 1 out of 4. Because there's 1, 2 out of 4 possible outcomes. Then we spin it again, and we have to get even. Even, there are 2 even ones, 2 even numbers out of 4, 2 fourths. I could reduce this, but we'll just multiply 1 times 2 is 2, 4 times 4 is 16, put it in simplest form. The probability of getting a 2 and then an even is 1/8. Let's try another one. Let's try some cards. And let's say I have 5 cards, okay? And I want to get the probability of getting 5 and then odd. Well, the first question you should be asking yourself is, after I draw a card, am I going to put it back in the pile for the second one? Because that makes a difference. If I put it back in the pile, then the 2 events are independent. If I remove it from the pile, the events are dependent. Now, the first 2 examples we had so far have been independent events. So let's do this one as a dependent event. In other words, I'm going to mix these cards up. I'm going to pull one, see what it is, and then I'm going to throw it away. So I've mixed up the cards randomly. I'm going to go ahead and pull one. Okay, and it's 7. Okay, now for the second drawing of a card, I'm not going to use the 7. I'm going to put it aside. All right. Now you see this time there's only 5 cards to pull from. Okay, so I mix them up this time and draw. Let's say I get a 5 this time. Okay. All right. So anyway, we got to figure out what is the probability of getting 5 and then odd. As you know, these are our cards. Okay, so the first time we draw, there are 5 cards in here. Okay, and so the probability of getting a 5 on the first draw is 1 out of 1, 2, 3, 4, 5. Okay, now if I do draw the 5 the first time, like it says I should, I can get rid of the 5. Now I only have 4 cards to draw from. And for the second draw, I'm saying what are my odds of getting an odd card, an odd numbered card. Now you can see there's only 4 possible outcomes. How many of them are odd? 2 of them are odd. Okay, so we'll do 1/5 times 2/4 to figure out the probability of this dependent event. 1 times 2 is 2. 5 times 4 is 20. Put that in lowest terms. 1 out of 10. That's what you'll be doing in IXL today. Good luck.